Hello and welcome to How to Econ. Let's take a look at the market equilibrium and the four-step process that helps us find the market equilibrium when there are some changes in the market. Before continuing with this video, I hope you remember what demand is and what supply is. If you forget what they are, please check out the videos about demand and supply first. Together, demand and supply determine the price and the quantity that will be bought and sold in a market. The combination of price and quantity, where quantity demanded is equal to quantity supplied, is called the market equilibrium. The price level that allows quantity demanded equal to quantity supplied is called the equilibrium price. And at the equilibrium price, we have the equilibrium quantity. Equilibrium quantity is equal to quantity demanded and is equal to quantity supplied. Because the graphs for demand and supply curves both have price on the vertical axis and quantity on the horizontal axis, the demand curve and supply curve for a particular good or service can appear on the same graph. The graph on the screen illustrates the interaction of demand and supply in a market for gasoline. The upward sloping curve is the supply curve with the letter S next to it. S stands for supply. The downward sloping curve is the demand curve with the letter D next to it. D stands for demand. The point where the supply curve S and the demand curve D cross each other is point E. That is the market equilibrium. The letter E in economics often stands for equilibrium. At point E, you follow the horizontal dashed line to the price axis. You see number 1.4. That means the equilibrium price is $1.4 per gallon of gasoline in this case. At the equilibrium point E, you follow the dashed line straight down to the horizontal axis. You see the number 600. That is the equilibrium quantity, 600 million gallons. If you had only the demand and supply schedules and not the graph, you could find the equilibrium by looking for the price level at which quantity demanded equals to the quantity supplied. The word equilibrium means balance. That's what we all want in life, isn't it? A market wants the same thing. If a market is at its equilibrium, then it does not want to break that balance. However, if for some reason a market is not at the equilibrium, then economic pressures arise to move the market towards the equilibrium. Imagine, for example, that because of some unparticular reason, the price of gasoline was above the equilibrium price. That is, instead of $1.4 per gallon, the price is $1.8 per gallon. The dashed horizontal line at the price of $1.8 in the graph helps us find the new quantity demanded and new quantity supplied when the price is $1.8 per gallon. At this higher price, consumers find ways to use less gasoline and buy less gasoline. The quantity demanded drops from 600 to 500 million gallons. You can see the dashed line at $1.8 cuts the demand curve at point A. From point A, you follow the dashed line straight down to the horizontal axis. You see the number 500. That is the new quantity demanded when the price is $1.8 per gallon. However, at this higher price of $1.8 per gallon, the quantity of gasoline supplied rises from the equilibrium quantity 600 to a new level, 680 million gallons, because the higher price makes it more profitable for gasoline producers, and they want to sell more. You can see the dashed line at $1.8 cuts the supply curve at point B. From point B, you follow the dashed line straight down to the horizontal axis. You see the number 680. That is the new quantity supplied, 680 million gallons when the price is $1.8 per gallon. So when the price is $1.8 per gallon, the quantity supplied is 680 million gallons, which is higher than the quantity demanded, which is 500 million gallons. Since quantity supplied is not the same with quantity demanded, the market is off balance or not at the equilibrium. This is what we call a surplus or excess supply. It happens when quantity supplied exceeds the quantity demanded. In this example, there is a surplus of 180 million gallons. You take the quantity supplied 680 minus the quantity demanded 500 to get the surplus of 180 million gallons. The opposite of surplus is shortage or excess demand. It happens when the quantity demanded exceeds the quantity supplied. For example, if the price is at $1.2 per gallon, below its equilibrium level. Using the dashed horizontal line at this price, you can see that the quantity demanded increases from 600 to 700 million gallons. As people start to drive more when gas is cheap, maybe they drive to work more instead of taking buses or buy larger cars that are less fuel efficient. However, lower gasoline price reduce gasoline producers' incentives to produce and sell, and the quantity supplied falls from 600 to 550 million gallons. Again, you can find this new quantity demanded and quantity supplied by following the dashed line at the price level of $1.2 and see where does it cut the demand and supply curves. In this case, there's a shortage of 150 million gallons. So once again, you see that the market is off balance or not at the equilibrium. There will be pressure for the market to find a new equilibrium whenever the market is off the original equilibrium due to the impact of some events. To estimate a new equilibrium in a market after some events happen and push the market out of its original equilibrium, we use the following four-step process. First step, draw a demand and supply graph before the event took place. Second step, decide whether the event affects demand or supply. Third step, decide whether the effect causes a curve shift to the left or to the right, and then sketch the new curve on the diagram. The fourth step, identify the new equilibrium and then compare to the original. We will look at 3 examples on a cherry market. First of all, in part A, we will apply the 4-step process to see what happens to the equilibrium quantity and price if the price of oranges increase. Assume that cherries and oranges are considered substitutes. In part B, we will see what happens to the equilibrium quantity and price of cherries if there is technological advance that allows cherries to grow faster and have higher yield. Finally, in part C, we will see what happens to the equilibrium quantity and price if 2 events in part A and B happen together. That means the price of oranges increases and there is a technological advance that allows cherries to grow faster and have higher yield. Let's start with part A. What happens to the equilibrium quantity and price on a cherry market if the price of oranges increases? Step 1. Draw a demand and supply graph before the event took place. This simple graph on the screen has the supply and demand curves for cherries. The vertical axis shows the price, the horizontal axis shows the quantity. The exact units of those 2 axes are not important for now because we only want to focus on the movements of the market forces. The demand curve cuts the supply curve at point E1. Point E1 represents the original equilibrium on this cherry market. The original equilibrium price is P1 and the equilibrium quantity is Q1. Step 2. Decide whether the event affects demand or supply. Because oranges and cherries are assumed to be substitutes, that means when oranges become more expensive, people will switch to buying more cherries at any given price. More people are willing and able to buy cherries mean higher demand for cherries. Step 3. Decide whether the effect causes a curve shift to the right or to the left, and then sketch the new curve on the graph. Higher price of a substitute, oranges in this case, is one of the 6 demand shifters. It will increase the demand for cherries, and the demand curve will shift to the right. The graph now has the new demand curve D2 on the right-hand side of the old demand curve. Step 4. Identify the new equilibrium and then compare to the original. As you can see on the graph, the new demand curve D2 cuts the old supply curve at point E2. This is the new equilibrium in this cherry market. The new equilibrium price is P2 higher than P1. The new equilibrium quantity is Q2 higher than Q1. So when the price of oranges, which are substitutes for cherries, increases, demand for cherries increases as well. As a result, equilibrium price and equilibrium quantity for cherries increase. Now, let's take a look at the second example. Part B. What happens to the equilibrium quantity and price on a cherry market if there's a technological advance that allows cherry trees to grow faster and have higher yield? Step 1. Draw a demand and supply graph before the event took place. This graph has the supply and demand curves for cherries. The vertical axis shows the price, the horizontal axis shows the quantity. The demand curve cuts the supply curve at point E1. E1 represents the original equilibrium on this cherry market. The original equilibrium price is P1 and the equilibrium quantity is Q1. Step 2. Decide whether the event affects demand or supply. Because the technological advance allows cherries to grow faster and have higher yield, sellers are willing to sell more cherries at any price level. That means the price for cherries increases. This is an example of a supply shifter. Step 3. Decide whether the effect causes the curve to shift to the right or to the left, and then sketch the new curve on the graph. An increase in supply is demonstrated on the graph by a shift to the right of the supply curve. The graph now has a new supply curve S2 on the right-hand side of the old supply curve. Step 4. Identify the new equilibrium and then compare to the original. As you can see on the graph, the new supply curve S2 cuts the old demand curve at point E2. This is the new equilibrium in this cherry market. The new equilibrium price is P2 lower than P1. The new equilibrium quantity is Q2 higher than Q1. So when there is a positive technological shock like in this example, supply increases. As a result, the equilibrium price decreases and the equilibrium quantity increases. Let's make it a little more interesting by allowing these two events happen at the same time. That means we will look for what happens to the equilibrium quantity and equilibrium price when we have the price of oranges increases and there is a technological advance for cherry trees. Step 1 and step 2 are still the same with before. We draw the same original demand and supply graph in step 1 with the original equilibrium price P1 and equilibrium quantity Q1. Then we decide whether these two events affect demand or supply of cherries. As we analyzed in the first two examples, when orange price increases, demand for cherries will increase. When there is a technological advance for cherries, cherry supply will increase. For step 3, we draw the new demand and supply curves on the right-hand side of the old curves to depict increases in demand and supply. For step 4, we see that the new demand curve D2 crosses the new supply curve S2 at the new equilibrium E2. At E2, the new equilibrium price is P2 and the new equilibrium quantity is Q2. It looks like the equilibrium price has increased and the equilibrium quantity has increased as well because of the impact of two events. However, there is the fun part. For the situation in which we have more than one event, we have to be careful about our observations. While we are skipping all the mathematical details for now, keep in mind that if an event has a really big impact on the market, the curves will shift further away. And if an event has a small impact on the market, the curves will not shift too far. Based on how far or how close the curves shift, the final impact on the equilibrium price and quantity might change. For example, assume that the shock on the supply side is very significant, so it has stronger impact on the market than the shock on the supply side. That means we assume that the technological advance is so good that it increases supply of cherries a lot. So on the graph, the supply curve shifts very far to the right. Instead of shifting to S2, the supply curve shifts all the way to S3. Now the new equilibrium is actually at E3, where S3 cuts the new demand curve D2. The new equilibrium price is P3, lower than P1. The new equilibrium quantity is Q3, higher than Q1. So you can see that now the equilibrium price actually decreases even though the equilibrium quantity still increases. The conclusion for this example is that when orange price increases and there is a technological advance on cherries, the equilibrium quantity will increase for sure, but the impact of these two events on the equilibrium price is ambiguous. We say ambiguous because these two events could either increase or decrease the equilibrium price, as I have shown you. Depends on how significant each event's impact is. Unless we know more information about the situation, we cannot say for sure whether the price could go up or down. That's why we conclude that the impact on the equilibrium price is ambiguous. This example of two events happen at the same time reminds us to always double-check our answer, especially when there are more than one event happening. In many cases, the impact might be obvious on the quantity and ambiguous on the price, like the example that we just did. In other situations, the impact on the price might be clear, but the impact on the quantity might be unclear or ambiguous. Let's do one more example about this four-step process and two events on the market, shall we? What happens to the equilibrium quantity and equilibrium price of cherries in the United States if the American government reduces the number of harvesting visas for foreign workers, and popular scientific research from Harvard shows that eating cherries is good for our hearts? If you want to give it a try, please pause this video and apply the four-step process to see what you get. I recommend you to have some scratch paper and a pen for practice. If you are not familiar with the four-step process yet, and there are at least two events happening at the same time on the market, it is easy to be confused and get the wrong answer. But don't worry, with more practice, you will feel more comfortable with this process and get the right answer quickly. Students are often not a big fan of graphs, but economics is actually very intuitive. In many situations, you can use common sense to solve each piece of an economic question and then combine them together on one graph to get the final answer. Again, pause now if you want to try it before seeing the answer for this example. Now, first step. You need to draw a basic demand and supply graph. In my graph here, S1 and D1 represent the original supply and demand curves. They cut each other at the equilibrium point E1. At E1, the original equilibrium price is P1 and the equilibrium quantity is Q1. Second, You have to decide whether each event affects demand or supply on this cherry market. If the American government reduced the number of harvesting visas for foreign workers, American cherry farms will lack people who can harvest cherries for them. And because cherries have a very short harvesting window, they turn bad quickly if they are not harvested on time. Cherry farms have to hire local workers, but there might not be enough local workers, or they might ask for higher compensation than foreign workers, which would increase the cost for cherry farms. This means cherry supply could decrease, and it means the supply curve will shift to the left from S1 to S2. At the same time, popular scientific research from Harvard shows that eating cherries is good for our hearts. You know, there are millions of people who have some types of heart conditions in the United States. If more and more research shows the benefit of cherries for our hearts, many people would start consuming more cherries. So demand for cherries could increase. The demand curve shifts to the right from D1 to D2. The new demand curve D2 cuts the new supply curve S2 as the new equilibrium E2. At E2, the new equilibrium price is P2 and the new equilibrium quantity is Q2. It seems like both the equilibrium price and quantity have increased. However, do not stop there. We have two events happen at the same time on the same market, affects both sides of the market, so we have to double check our answer. Assume that the negative shock on the supply side is so big that cherry supply decreases significantly. The supply curve shifts further to the left from S1 all the way to S3 instead of S2. Here, we can see that the new supply curve S3 cuts the new demand curve D2 at the new equilibrium E3. At E3, the new equilibrium price is P3 and the equilibrium quantity is Q3. While the price appears to keep increasing no matter what, the equilibrium quantity now has decreased. Q3 is smaller than Q1, the original quantity. So we can conclude that when there are less harvesting visas and more proven benefits of eating cherries for our hearts, the equilibrium price of cherries in the American market would increase, but the impact on the equilibrium quantity is ambiguous. If you tried it yourself, I hope you got the right answer. Keep practicing and you will become more comfortable with applying the 4-step process. That's it for now. Thanks for watching and have fun practicing. Bye.